focus of this lesson will be on using our parallelogram properties in our proof. We have at the top of the page this list of all the properties of parallelograms that we've discussed before and you've seen before in your previous math classes. And now we're going to use these properties in our proof writing. So let's go ahead and let's get down to it. In number one, we're told that figure JKLM is a parallelogram and that segments JO and LL are congruent to one another. We're being asked to prove that segment OP is congruent to segment OQ. Just like always, I want to mark the given information in the picture. However, parallelograms have so many properties, so many pairs of congruent segments and angles, that it's kind of tough to mark them all in the picture, and to do so would be rather cumbersome and overwhelming. So the way that I'm going to show where I'm going to mark a parallelogram is I'm going to get my highlighter out and I'm going to highlight it. And once I highlight that figure, I acknowledge that it's a parallelogram with all of the properties of parallelograms that come along with it. Opposite sides are congruent, opposite angles are congruent, so on and so forth. I do know also that segment JO is congruent to segment OL, so I'm going to mark those in my diagram. And what I'm trying to prove are those two pairs of congruent segments. So I know that if I could prove a pair of triangles that contain those segments congruent, those segments would be congruent by CPCTC. So my strategy here is going to be to prove that those two yellow triangles are congruent. Once the yellow triangles are congruent, CPCTC will lead me to the segments. You might be saying, well, Ms. McCann, how are you going to get those two yellow triangles congruent to one another? I'm going to use the properties of that parallelogram. For instance, I know that in a parallelogram, opposite sides are parallel. So that tells me that the top side and the bottom side of this figure are parallel. Once they're parallel, the alternate interior angles along each transversal will be congruent. Therefore, angle 1 and 2 will be congruent to one another, as will the alternate interior angles along the other transversal. That makes angles 3 and 4 congruent to one another. You might be saying to yourself, well, I wanted to use those vertical angles around point O, and you would be right. You could use those vertical angles around point O if you wanted to. In the interest of keeping my proof as brief as I can, I'm going to use both pairs of alternate interior angles and prove the triangles by angle, angle, side. But again, you could do angle, side, angle as well using those vertical angles around point O. All right, so let's go ahead and let's get down to writing this proof. I'm going to start with the fact that JKLM is a parallelogram. Because he's a parallelogram, I know that the top side, JK, and the bottom side, ML, are parallel to one another. And that's because parallelograms have opposite sides that are parallel. And then once those sides are parallel, I'm all set up nicely to conclude that angles 1 and 2 are congruent, as are angles 3 and 4. The other piece that I need in order to prove my triangles congruent are the given segments, JO and OL. And now I've got everything put in place nicely to go ahead and prove those triangles congruent. Remember, when you name the congruent triangles, you must match up the congruent corresponding pieces. So triangle JOP is congruent to triangle LOQ. And once those triangles are congruent, CPCTC will lead me to the pair of congruent segments that I was looking for. So all of the great proofwriting strategies that we've worked so hard to develop are still coming into play here. Everything you know about congruent triangles still works. Everything you know about parallel lines. Really, the piece that we're adding that's a new piece here is this whole notion about using the parallelograms and their properties. All right, let's go on to the next proof. In this one, we're told that figure ABCD is a parallelogram. And again, I'm going to start by anything that I know is a parallelogram, I'm automatically going to use a highlighter with, because there's too many properties to mark in the picture. That should say D is the midpoint of segment AE, so there's a little typo there that we're going to go ahead and correct. And once I know that D is a midpoint, I know that that makes a pair of congruent segments, so I'm going to take care of getting those marked in the picture. And what we're trying to prove in this problem is we're trying to show that triangle DCE, so that little purple one right there, is congruent to triangle CDB. That little purple one right there. So we're trying to show those two purple triangles congruent to one another. Well, due to the fact that the blue figure is a parallelogram, I know its opposite sides are congruent. So the left side of the blue parallelogram has to be congruent to the right side. That gives me one pair of congruent parts in the purple triangles. DC is a shared side between the two. That gives me a second pair of congruent parts. And because the blue figure is a parallelogram, I know that its opposite sides are parallel. And if its opposite sides are parallel, that's going to set me up very nicely for some pairs of congruent alternate interior angles. These are a little bit trickier to find than the ones in the first picture. So I'm going to go ahead and extend the left side and the right side. And if I'm looking along that transversal that goes right down the middle, and the reason I picked that transversal is because it's shared by both of the triangles. I know that that angle right in there, that red one formed by the parallel line and the red transversal, is congruent to that angle right in there, formed again by the parallel line and the red transversal. Those are a pair of congruent alternate interior angles, which will set me up very nicely for the side angle side scenario, and will prove the triangle's congruent. So that's my strategy. I want to prove the triangle's congruent by side angle side. So I need to talk about side DE being congruent to side BE. This is probably the trickiest pair of congruent parts that I have to talk about in these triangles, because I actually used two of the givens in order to obtain those parts. I used the fact that segment or figure ABCD is a parallelogram with its congruent opposite sides, and I used the given that DE was the midpoint, making those two pieces congruent. So I'm going to go ahead and start by talking about the fact that ABCD is a parallelogram. And because he was a parallelogram, that's what gave me the opposite sides congruent to one another. So that gave me segment AD congruent to segment BC. And that's because a parallelogram has opposite sides that are congruent. The midpoint is what gave me segments AD and DE congruent. And a little bit of substitution will give me with the sides that I wanted for the purple triangles. So AD and BC, AD and DE, the one that's repeated here is AD, so I can go ahead and substitute. And that'll leave me with segment BC congruent to segment DE. And if I look up in the picture, these are the sides in the purple triangles that I was looking for. The next pieces that I want to talk about are these congruent angles. I knew those fellows were congruent because of the parallel lines, and I knew those lines were parallel because of the parallelogram. So this is a little bit interesting in that not only am I using the parallelogram to get the opposite sides congruent, but I'm also using the parallelogram to get the opposite sides parallel. So segment AD is congruent to side BC because the parallelogram has parallel opposite sides. And it's those parallel lines that are going to give me the angles that I'm looking for. I want to go back, and I said parallel but wrote congruent, so let me go back and fix that. So that makes angles 1 and 2 congruent to one another due to the fact that parallel lines have congruent alternate interior angles. So I've now talked about the left side, or the one pair of sides. I've talked about one pair of angles. The last piece that I need to mention in my proof is side DC congruent to itself by the reflexive property. And once I write about that, then I'm all set up nicely to go ahead and make the conclusion that these triangles are congruent by side angle side. So again, there's a lot that's the same about this from the proofs that we've written before. Really, the only new piece that we're introducing here are these parallelogram properties, and it's really important that you be familiar and comfortable enough with those properties so that you are able to translate them or bring them into your proof writing process. As always, I do want you to take a few minutes and summarize in your own words the key ideas and the important takeaways from this lesson, and then on the next page, see what you can do with number 2. But let's make a good effort on number 2, and then you can skip number 3. You don't need to try that one.